Visitor design pattern. So we talked about a structural design pattern, that is a decorated design pattern. So in decorated design pattern, we add attributes. So it's a kind of whatever the class we have, and inside the class, if I want to add attributes, then we place wrapper classes on top of it, being they derive from the same interface. So wrapper class function what we want from the concrete class, we call the same function through the same interface. This is what we saw. And the wrapper, they add their functionality and they call the next level, next level, next level, till till it reaches the actual, the kind of actual decorative, that is the end one, and then it does the job. So this is decorated design pattern. So this comes under a structure because we change the complete structure following an interface, and the code which is written using the interface to call a certain operation on the decorative, it is blocked by decorator class instance following the same interface, and then they get called and they have the other classes as containment. So this is decorator, and suppose there is only one decorator. This is decorator and this is concrete class. User calls the decorator's function considering that it is concrete class. It does its work and then finally call the concrete class. So there is extra kind of attribute that we get, like a printing border along the page. So before it prints the data on the page. Now visitor design pattern. So visitor design pattern comes as if you want a behavior at runtime. Okay. So there is a class and it has set of behaviors, like kind of like it has so many things, and it wants a behavior like it kind of it has uh, I believe we are taking example of printing. So it has methods to print. So print on inkjet printer and print on kind of dot matrix printer, and now it wants an operation to print on kind of a laser print. So inkjet printer and dot matrix printer, it has a function. Now it wants to print on a laser print. So that is the new kind of operation it wants. Or if we take the previous example, then if it is has a printing option, then it wants a new thing that is printing the border. I mean, let's say, continue with the same thing. So in the decorated design pattern, we had a printer and it used to print the data at the center of the middle area of the page. If you want the border, then we added the attribute in a terms of a new class, and that becomes a wrapper over the previous class and they follow the same interface. Now in visitor design pattern, if I want a new operation, there I call it new attribute. I call it here as new operation. So new operation being like printing a border on a particular. So I have a printer, but printing border is missing. So whatever the operation we want, so for that operation, we can have a separate class. It's like same thing. Now now we have printer class and we have a separate. Now we want 15 separate operations. For 15 separate operations, we need 15 classes. The way it is in decorator. But decorator and the concrete type, they derive from the same interface. Here, whatever the operation we want, all they derive from a kind of separate class called visitor. Now, what I have a printer class that is already I have, and I want border printing. So border printing would inherit a separate class called visitor. So visitor is interface. Okay. Now In the printout, suppose first I want a border to be printed. I say there is a function, whatever we have written the printer, so we'll introduce a function called accept. Accept is a virtual function. So I have a ready-made printer which prints nicely. And there, as per design, we place a function called accept. That's it. Accept accept a visitor pointer. Already have a printer. Now I want 15 new functionality in the printer, operation on the printer. I have 15 different classes. All they derive from visitor class. And now this printer has a function called accept. Accept takes visitor point. Now, if I want border to be printed, then border visitor that derives from the visitor. I say accept border. Okay. Now, in the accept code of maybe it will come in the interface of the printer. It calls the visit. So I call accept against the printer. Accept calls the visit against the uh, a visitor, and visitor would get the visit function called. Getting the this pointer, because if you call the function in interface programming, you receive the this pointer. So or self in the Python. So you receive the this pointer as whoever called you. So whatever printer we have, inside the printer I have function accept. Accept the visitor pointer against the visitor pointer, which is polymorphic. We call a function called visit and pass self. Now visit get called in the visitor, and who called it, that pointer I received. Okay, so I have a printer, it wants a new operation to be done. So there is a function called accept, which takes the visitor pointer, that is polymorphic. Against the visitor pointer, it calls function called visit, passing self. Now, inside the visit of the uh, of the visitor, it receives the object through the interface. Which object needs to be visited? Done. So now visitor. So if I want border to be printed, I get the pointer of the printer. So printer had everything, paper and what needs there. So it knows the printer. Since it is written specifically, this new operation is written specifically. If suppose if I have two printers, one is letter printer, inkjet printer. If they pass self, then it has two visits. One visit is for laser, one visit is for uh, inkjet. But it doesn't care. It calls visit passing its pointer. Now it gets that visit called, and then it knows that it is laser or it is inkjet. Then, based upon that, first it places the border, because this is the border operation, and it is called dual dispatch also. We are doing dual dispatch in the sense we are calling visitors visit, and visitor visit is receiving the concrete class on which it has to visit. Then it calls those functions against the class, and first it does it work, and then it does call the print that anyway it prints. So this is visitor design pattern. So visitor uh, we saw like decorator design pattern where we add attribute. Here in visitor design pattern, we add operation. So operations are added. Each operation is given a class structure, and those classes have functions called visit. And against the visit, who the concrete class for which operation need to be added, it passed through. So the visitor operation, that is in terms of class, they receive pointer of the object that they need to serve, and after that they can do their work, add their operation, and then call this point. So this is a typical a decorator and visitor design pattern. I mean, if you want to know more, then you can visit our website. and there we have two disclosures. One is C++ and one is Perl on the on the uh, on the this design patterns. There, visitor and decorator can be. Visitor is little bit little complex because it is dual dispatching. So I have a concrete class, I have a visitor class. Concrete class we call accept, passing the visitor class, the visitor which needs which operation I want to add against the visitor, it call the visit, passing its own pointer. So visit gets the pointer, and if visitor has is serving so many classes, so for so many visit, like if it is a kind of adding border and adding border to five different printers, in five different visit it writes because functions can be overloaded, and the particular visit based upon the pointer type, based upon the pointer type it would receive, and then since we are receiving the concrete class, so this guy call this and passing its own pointer, and then again this pointer it starts calling the function. First it serves what it is supposed to, and then it kind of does it work. So calls first it serve and then call. So this is dual dispatching in the visitor design. Okay, so a scenario comes as what is the real life scenario. So we are giving example of Genghis Khan army. So Genghis Khan army is supposed to be kind of many Nadir Shah, means we're talking about Asia, but anyway there are other warriors also like Alexander Al Sikand. So he was also kind of uh, invincible, we can say. So Genghis Khan army style. So one we talked about uh, in the structural design pattern, where cavalry can be added. Like if camel cavalry is missing, then it can be added, and it can be added in a way that there would not be any headache. So it could just fit in because it is following the interface. Now, since we are talking about adding operation, then like five horses are falling, means during the war, five horses are falling on the ground, and five horses need to be replaced. So that is the scenario. Now the horse filling, that is a separate class. So against that, so we can say that please visit. So we can through accept, we call horse filling department and passing the horse cavalry as a pointer. Now the horse filling department receives the request as as horse filling, because horse cavalry we are passing it. So there are two things. There are camel cavalry, horse cavalry, elephant marching, and then soldiers marching. There are so many classes. So horse cavalry class would call visit through accept and then finally visit inside the class called filling, just filling. So the filling is a visitor. Inside the filling we have visit, and then filling for horse visit, filling for camel visit, filling for marching, elephant marching. Like these are the visit, means override function. When I pass horse cavalry, then immediately that function get enabled. Visit horse cavalry. Now, it not only knows how to fill it, it gets the pointer also where to fill it. Interface based programming. Now, it fills five horses at runtime because it knows where to fill it, because full horse cavalry data structure it is receiving. Full camel cavalry data structure it is receiving. Filling department. Okay, there can be other department where everyone is alive, but the person sitting on the horse, he loses the archery somehow. So archery department it would go. Class is a new class there. There we need a new kind of archery to be filled in. It receives horse cavalry as a pointer. Then it can do its operation, and then it knows the status of horse cavalry, how many has fallen, and what is the current status of the war. Means Genghis Khan was amazing. Okay. probably in the like the new era of the history where it starts from Gautam Buddha, like king like Ashoka. So from there, the new era in the history starts. So probably Changej Khan means if I do the kind of the numbering, who win how many wars, then he was parallel to King Ashoka. So the way he fought the war means bringing in over the kind of in the war surprisingly bringing in camel cavalry automatically, or if any horse is falling, then five horses he would replace quickly, and his army would be same when it going at the sunrise and it is coming at the sunset. No change in the how someone can win. Not possible. Means people expect that as the day climbs, then a army would decimate slowly, and there is chance for the other team to dominate. But if it is everything is exactly same at the noon time and in the post noon, then you cannot win. So how you fit in the other cavalry and at run time you change things as per the design pattern, that was classic of Genghis Khan. So he was invincible. So this is the way, like we have filling department, we have archery department. So many new operations are there. They follow same visitor pointer. If anything need to be filled, like filled, then filled visitor would be called passing the horse cavalry pointer. Horse cavalry pointer, then that particular function, visit function, again the horse cavalry pointer would get called. And then with the pointer of the horse cavalry, so he's browsing everything. That what is the situation and how where the horses are and those kind of things. And then it can fill through the interface quickly. Genghis Khan was an architect. This is what I would say, that he was not a warrior only. He was an kind of a top class architect. So this is a decorator, a structural design pattern, and behavioral design pattern, visitor design